Hey, I'm Scott Hanselman, and it's another episode of Azure Friday. I'm going to be talking with Dr. Ranveer Chandra and his team about how they're taking years and years of research from Microsoft Research and putting it into the hands of farmers and agribusiness to make food better for everyone. Hey friends, I'm Scott Hanselman and it's Azure Friday. I'm here at Microsoft Ignite in Orlando with Dr. Ranveer Chandra, and we have a lot of really cool equipment here. This has got to be the best booth of any booth at Ignite.
Thank you, it is. We've got a tractor, we've got an entire farm, and we're showing how you can enable data-driven agriculture with FarmBeats.
Data-driven agriculture. How do people do agriculture today? They just feel this ground is dry, I need to water it.
Yeah, so a lot of farming is based on guesswork. Most of the decisions that a farmer takes about when to water, when to apply pesticide, when to apply nutrients, fertilizer is based on guesswork. And we believe that instead of using guesswork, if a farmer uses their knowledge coupled with data and data-driven insights, we can make agriculture more productive, more cost efficient, and it's also better for the environment. And that's what we mean by data-driven agriculture.
Okay, so where does this data come from, though? I mean, I can buy a little stick that tells me the pH, and I can check for nitrites and stuff, but if I really want data about my soil, what do I do?
Yeah, so this data that people talk about, one of the ways is to get sensors in the farm. Like some of these sensors that our partners make. This is made by Teralytic. This is made by Davis Instruments. These sensors can go inside soil and gather large amounts of data. For example, this particular sensor has about 26 different types of sensors. It measures nutrients, it measures moisture. Wow. This thing here from Davis, it measures wind, humidity, a lot of parameters about what's happening in the farm at that point, at that location. One of the challenges, of course, as well, these sensors, they need to communicate. They need to send the data to the cloud to make sense of it. Most of these farms are disconnected. They are far away from the cities. They don't have any internet access, because of which existing solutions quickly become expensive. To solve this problem, one of the innovations we have in FarmBeats is what we call the TV white spaces. What you're seeing this antenna here, you remember this, you used to watch TV with these antennas.
UHF.
Exactly. You used to flip through TV. On certain channels you saw a transmission, other channels all you saw is white noise. What we've been doing in research for about 14 years now is developing a way where in those noisy channels you can put Wi-Fi signals. And the advantage is, compared to Wi-Fi at the same power level, in UHF TV channels, your signals go 4 times farther.
So you're tunneling data transmissions inside of the static, in the in-between spaces between channels.
Exactly. And because these channels are lower in the frequency domain, your signals go really far. And the interesting thing about agriculture is that the TV towers are in cities where people are. If you go to farms, most of these channels are just white noise.
Wow.
The more white noise channels there are, the more unused capacity there is.
Right.
So you can then start sending data from these different sensors all the way to Azure, to the cloud, where we can start aggregating a lot of this data from the farm.
Right, because Wi-Fi would be like in the gigahertz range, 2 or 5 gigahertz. We're talking about the low megahertz, big sweeping waves that can go very long distances. That's brilliant. Okay, so I've got the sensors, but I want to get imagery. I want more pictures. I want more detail.
Right.
What's going on behind you here?
Yeah, the interesting thing is sensors would only tell you what's happening at that location. It won't tell you what's happening 10 meters away. And so if for example the problem was what is the soil moisture level 6 inches below the soil throughout the farm, you would need a sensor every 10 meters. But putting one of those sensors every 10 meters is expensive to deploy, to manage. It'll come in the way of the farmer as the farmer does the day-to-day job. So the key technique we built was a way to combine ground sensor data with aerial imagery, so that with very few sensors and with aerial imagery from, say, drones or robots or satellites, you can then train a machine learning model to then start making predictions in other parts of the farm where you do not have sensors. And what we showed was, using this technique where you combine ground sensor data with aerial imagery from drones, robots, or even from satellites, you can then build these maps which are 3 times more accurate than if you did not use this aerial imagery.
Interesting.
So here what you're seeing is, this is a drone from DJI, which is one of the partners. This is a fixed wing drone from SenseFly. There, what you're seeing is an EarthSense robot. This thing goes between rows. This has multiple cameras. This has a LiDAR sensor as well. And this is another camera, slant range, which gets frequencies in different parts, which gets images in different parts of the spectrum, optical images, which you can then analyze and get information about crop stress, soil stress, and different things which you just couldn't get until now.
That's interesting that you point that out, because you're using the electromagnetic spectrum in a creative way by tunneling data there, and you're not just taking visible light. You're using as much of the spectrum as would be appropriate.
That's right.
That's really exciting. Okay, so I've collected all this data, presumably terabytes of data over hundreds of acres.
Yeah.
What do I do with it then?
Yeah, so all of this data then goes to the cloud. What we built with Azure is Azure Data Hub, where all of this data is put in one place in the cloud, and then we apply AI and machine learning on top of this data to combine these different data streams to start adding value. Like what you're seeing here, this is one of the dashboards. This is a solution. This comes as a solution accelerator with our FarmBeats offering. In this dashboard, this is actually a real farm.
Really?
This is Andrew Nelson's farm in eastern Washington.
Wow.
He's a 5th generation wheat farmer. And in his farm, what you're seeing is in his entire farm, we divide them into fields.
Okay.
And here what you're seeing is for each field, this is for example telling you how the soil moisture is varying throughout the field. We combine this with sensor data to build these indices. EVI is the vegetation index, which tells you how his crop is doing, whether they are in stress. This is NDWI, which tells you the water index, how the water levels are varying in the farm. And the way we build this is by combining data from sensors, from satellites, from the drone imagery, which all comes to the cloud, where we then merge all of this and present all of these insights to the farmer.
So how does he take those insights and say, well, this is meaningful to me, there's something happening here, and then take action on that?
Yeah, so one of the things we do is we'd identify parts of the farm that are under stress, that don't look normal, using things like anomaly detection, and use that to flag this information to a grower.
Wow. So how does someone get this information? Is this something that costs millions and millions of dollars, or where do I find this data and this solution?
This solution, so the way we are taking this to market is an Azure Marketplace offering. So FarmBeats is now available on Azure Marketplace. Anyone can go there, install it. It would run in your subscription, in the customer subscription.
Oh, so it's not FarmBeats as a service, it's running in your Azure subscription.
Yeah, so the data, we don't own the data. The data is going in the customer subscription, where all of this data, they can then go there and sign up for partners, partner sensors, partner drone companies,
fantastic.
Partner data. And then FarmBeats is not built as a farmer-facing offering. It's not meant for the growers. It's meant for partners to build solutions on top. We provide these insights, but we want partners, ISVs, to build solutions on top of this for the growers. We are not an agriculture company.
No, that makes sense.
Yeah, but we are partnering with the agriculture companies to build these solutions.
So then if I were a fertilizer company and I was interested in selling fertilizer in the most effective way, then I might go and present that to a farm and say, I can help you use your fertilizer more effectively. I'll install these sensors, no cost, and then they get the benefit without the farm having to run an Azure subscription.
Exactly.
That's fantastic.
Yeah.
So if people go out and search for Azure FarmBeats, they can learn all about this. Can they make a demo farm if I just want to do one on my own?
Yeah, so you can go right now, install FarmBeats, get the satellite data and get the initial maps. To get additional insights, you would add sensors. To get more detailed insights, you would add drones. And we'll continue to add more and more partners to the ecosystem to start bringing more insights to that particular farm. Our vision with all of this, as I said, is to enable data-driven agriculture, but it's also to make it more affordable. That is, we want these solutions so that every farmer in the world can start getting data and start using this data for these data-driven insights. And towards that, we'll keep pushing the boundary of adding more partners, innovating on different things you could do on top, so that everyone can start benefiting from data and from the insights that can be generated on top of this data.
Fantastic. Thank you very much, Dr.
Thank you,
Chandra.
Scott. Yeah.
I learned all about Azure FarmBeats here at Microsoft Ignite in Orlando, and this is Azure Friday.